and Utility Solutions, Asia Pacific region of Trina Solar. Andrew is leading Trina Solar Asia Pacific region C&I and Utility Solutions business and is an accomplished energy and product management professional with over 12 years experience within the European, Asia, and Australian solar PV sectors. He has worked across a variety of disciplines within both utility scale and C&I, including roles in business development, cost estimation, project engineering and management, new market entry strategy, new product introduction, and O&M. He is also an accredited designer for grid-connected PV system by the Clean Energy Council of Australia. Hi, Andrew. Can you hear me?
I can, yeah. Thank you, Carol. Can you hear me?
Okay. Thank you very much. It's your turn.
Sure. I'll just share my screen momentarily. Can you see my screen?
Yes, I can.
Okay, let me just swap that. So, good morning, good afternoon, good evening, everyone, wherever you may be. I'm Andrew Gilhooly. I lead Trina's solutions business for Asia Pacific, based in Melbourne in Australia, but also involved in the Israel market. I was over in Israel back in April, and absolutely staggering to see such tremendous growth in the market, especially with all of the innovation and things like solar agriculture, solar highways, and all of the emphasis on storage. And completely agree with Elad's comments there about the energy trilemma and why it's so important to deliver on all three fronts there. So it's a privilege to be participating in such an exciting market, and hopefully I have some interesting materials to show you. Just a bit about the history of Trina. We are unique in the solar industry as being the only module manufacturer to offer truly integrated racking and tracker, single axis tracker solutions that are truly engineered to accommodate the integrated package of Trina modules into a Trina overall solution. Back in 2018, we acquired a tracker company, and then in 2020, we made them a wholly owned subsidiary and rebranded to Trina Tracker, and we're now targeting to become number 3 globally in global tracker shipments. We've deployed 7 gigawatts over more than 10 years into every major global market. By the end of this year, that'll be over 8 gigawatts. And we have localized production in Europe, in China, Latin America, and more recently in India, and looking at Australia also. So very, very formidable and well-proven track record. And, you know, with so many gigawatts being deployed over so many years in every market, we're seeing sites becoming more challenging now. The easier sites have gone, so now what's left are increasingly challenging in terms of irregular shaped boundaries. This is a 5 megawatt behind the meter project that we did with our 2 portrait tracker in Australia last year. Uneven terrain. We have special bearings to accommodate for that. Strong wind. Trina is one of the very few trackers to have deployed at scale in cyclonic regions. In 2018, we deployed 120 megawatts in the cyclonic region of Northern Australia. And being the first company to move to large format modules, 500, 550, 650, and being the only module company to offer an integrated tracker solution, we understand the complexities of incorporating these large modules into single axis trackers better than any other company. Also, sites are getting more challenging in terms of geotech. Either sites that are getting rockier where you need to pre-drill and use concrete, or on the other end of the scale, sites that have cohesiveless soil and we need to ram and embed down to 3 or 4 meters. We have the lowest foundation count in the entire industry. So with something that requires fewer foundations, that mitigates the risk around challenging soil. And we're also now seeing sites that are prone to flood inundation. So especially the 2 portrait tracker really caters well for that. So we have different types of trackers. We have what we call the Agile 1P. That's where there's a single module in portrait. That's a 2-row tracker where we have a slew drive gearbox that's motorized on this side and is connected through a rotating drive shaft to the next row gearbox that is not motorized. So this basically, through only driving 50% of the rows, We reduce the number of motors, the supply cost, but also reduce the number of motors that can potentially fail in service. So we say that this tracker is best for non-challenging sites because they have a connection row to row and they're better suited to flat sites. But if your site's not challenging, we think this is the way to go. Also for sites that have higher wind speed, this tracker is good for up to 60 meters per second. For sites that are more challenging, we think the 2 portrait Vanguard is the way to go. That's where there's 2 modules in portrait over the torque tube. There's no mechanical links east to west. Each tracker is driven independently through this central actuator that's motorized, and then we have slave actuators at each end that are connected with this rotating driveline. That really stiffens up the structure north to south and ensures that even with these large modules, 2.4 meters long each module, the tracker is completely safe structurally, zero dynamic risk. Also, you can see here there's a very, very clean structure, very few foundations, as low as 100 foundations per megawatt. And because there's no linkages east to west, we say that this tracker is better for sites that are uneven in terms of terrain, or because you don't have the links east to west, better for sites that consider solar and agriculture, or sites that are prone to flooding. The tracker is completely flexible in terms of what types of module, 550, 650 watt modules from Trina, 182 millimeter modules from competitors. As long as we remain within these boundary conditions as defined by the wind tunnel testing, we're completely flexible and we can use any module on the market. This is the multiple driveline concept. This is how we ensure that these large format modules are completely safe from a structural point of view. And unique to Trina, we use linear actuators rather than slew drives on the 2P because we're convinced that this delivers an even greater holding torque than other 2 portrait competitors who use slew drives on their trackers. Some pictures here from our 2 portrait in the field. This shows how we can unlock solar and agriculture. You've got really, really wide spaces between the rows where you do use the 2P. And when you have something with fewer foundations, you can elevate the whole structure without the same cost penalty as you would with a 1 portrait tracker. This is our patented spherical bearing. This is unique to Trina, where you have a rose joint that's fully articulated on the top of every pile. This shows how we can deploy on sites with highly uneven terrain without really any civil grading or cutting and filling. This is, as I say, unique to Trina. And when we put a dollar value on that, we find that this, compared to another 1 portrait tracker in Australia on a 300 megawatt project, we were saving 1.5 cents per watt through avoided cutting and filling. And then when we compare Trina 210 millimeter 540 watt to a competitor 540 182 on a 1P tracker, you can see we're almost at 40 modules in a string. The modules are almost the same size, but because our operating voltage is much lower, we can get more modules in a string. We have fewer motors per megawatt, more kilowatts per tracker, and fewer foundations per tracker. So all in all, that's 1.5 cent saving on the civils and about a net 1 US cent saving with a Trina 210 module on a 2 portrait tracker. We also provide our proprietary SCADA solution, so you can dial in and see each individual tracker, any fault codes, what angle it's currently at versus what angle it should be at. You can even control the trackers remotely to put them at maximum stow if there's forecast to be a hailstorm, for instance, and avoid micro cracking. So incredibly powerful O&M capability that comes from the integrated SCADA that comes with the tracker. Also, O&M is very important. Trackers do have motors and drives and things that move. You can see here on the preventative maintenance, it's very, very low. It's mainly purely visual and precursory checking. So only 158 man hours per 100 megawatts per year. And you can see here on the corrective maintenance, the failure rate of all of the key components here, the actuators, the drives, the bearings, they're all way less than 1%, 0.02, 0.04%. So very, very low O&M risk with a well-proven bankable tracker like Trina. We also utilize intelligent tracking to further boost the energy when you use bifacial modules on our tracker. So in heavy cloud cover or dust storms like you might get in Israel, it's better not to track with bifacial modules. So our controller and the pyranometers recognize this and put the modules flat automatically. Also on uneven sites during backtracking, we utilize machine learning to vary the tracking angle and avoid near shading on every tracker. So this can boost the energy further by an additional 3 to 8%. We also provide deep and close support at every step of your project in collaborating on reviewing the geotech and pull-out testing. And we send our engineers to train your installers, and we actually lead the commissioning process on the trackers. So full end-to-end support. We also have fixed solutions now, which are not just the tracker, which are optimized for the Trina bifacial modules to further optimize the bifacial pickup. In highly customizable in portrait or landscape orientation. And we just wanted to finish on a case study we looked at in Israel. One site was a constrained site, only 4 hectares, and another one was almost 12 hectares. And we looked at the value proposition for fixed tilt versus tracking. So if you look here on the top, where you were considering a constrained site with no storage, we could fit 8 megawatts of fixed and only 4 of tracking. So it was actually a tracking on beat the fixed tilt in terms of levelized cost of energy. But when you considered the capex of the storage and getting a better cycling of that battery, the fixed tilt came out ahead compared to the tracker. So we think that for constrained sites, less than 1.5 hectares per megawatt AC, fixed tilt is certainly the way to go. But where it got interesting was on the larger site, on the unconstrained site, we were fitting 17 megawatts of fixed tilt, but 14 megawatts of tracker. But in absolute yield, we were getting a very similar energy outcome, 31 megawatt hours per year, there or thereabouts. But with a much smaller DC system with the tracker, we were actually delivering a saving of 10% on the capex with the tracker. So that delivered a saving overall in terms of LCOE, in terms of with or without storage. So certainly on the larger sites, we see tracking becoming more viable compared to fixed tilt. And then just to conclude, at Intersolar, we recently launched our Elementor storage solution. So this is fully proprietary by Trina. We are fully flexible on DC coupled, AC coupled. It's liquid cooled. We have all of the integration and storage software smarts as part of the package, and we've gone vertically integrated. So we now control the IP from a cell and a module level into the overall package. So through vertical integration, we ensure a greater assurance in capability of supply in what's currently a highly disrupted supply chain environment. We save on the capex. It's an inherently more safe system because we have fire suppression and with it being liquid cooled, and we have enhanced performance. We have more effective cycling up to 10,000 cycles with the LFP chemistry. So we truly believe that this is the synergy of the Trina module, the tracker, and the battery can unlock more value for developers and IPPs in the Israel market. I'll probably conclude there because I've gone a little bit over time, but thank you very much for your interest, and we look forward to addressing any questions you might have after the webinar.